this is a Freedom node, right? It's got 3 radios. These little crescents represent radios. So the 2 5 gigahertz radios, say, are used for duplex meshing. That means it can establish a back and forth with 2 separate nodes. So that's what's happening here. Then the 3rd radio is used, like say this is your laptop, right? Is used to talk to clients.
And that's going to be 2.4
gigahertz, BG. So basically, you log onto your laptop, you pick up the signal from the node, you can access all the local services running on the node, you navigate to My Box or whatever, and it brings up your chat client, and your chat client says, oh yeah, like Johnny is over there logged into his chat client as well. Then if you want to have a chat with this person, right, the boxes are intelligent enough to know, oh, well, I'll just route that across. I have a direct link to that box. I'm not going to use the internet for this because that person exists in my sphere of material peer-to-peer communications. So then, let's say though that you're trying to talk to somebody in Taiwan, right? And
it'll find the fastest route through.
It'll find the closest gateway, so it'll hop here, hop out onto the global internet, and talk to that person. Now,
the closest gateway or the least cost gateway?
So,
like, is it
the routing over this mesh would be optimized link state routing, so the least cost gateway. It's not necessarily going to be the closest in the mesh, but OLSR does a good job of balancing loads and routing traffic to the most available gateway, essentially. So then sort of the next step, right, is like, let's imagine a situation where these are neighbors who have all just sort of plugged their Freedom box into their DSL port, right? Now what they can do is get together as a community and build a Freedom Tower. And then plug the Freedom Tower into, say, a fiber line that they light up. And now you're getting 100 megabits a second for your community. And the cool thing about network usage, right, is that it's asynchronous. So like, the actual amount of time that you're passing packets is really small, and most of the time the pipe lays dormant, which is why you have such massive savings when you pool your resources, and why they really don't want us to, is because then you realize 23.5 hours a day, that pipe is laying completely fallow. So you can put a lot more people on the pipe, and they just wait in the queue, and they get through. So then you
right, go, I understand.
Yeah, you get this part. Then so you can cut your DSL lines and all operate off of this community tower that you and that's the basic idea. And then so let's say this community has a tower, you build another tower, right? A neighboring tower. And then eventually these towers daisy chain all the way to a Freedom link, which is connected to the global internet and speaks BGP to the other networks, and then instead of buying bandwidth, you're peering. And that's where we want to get, where these collections of individuals who operate their little part of the network can come together and form their own ISP. This is basically build your own ISP.
How much bandwidth are these Freedom, are these 5 gigahertz radios capable of handling in their sphere?
So, at a certain point, you come up against physical limitations.
Yeah,
how much data can a wave carry?
How much data are we looking at with current chips?
So
in a given, I don't know how many mile radius.
Right. So on one of these links, we can get up with multiple input, multiple output, beam forming, like all of these tricks that we've developed over the last 5 or 10 years to increase the data rate on waves. We can get at least 100 megabits a second on one of these wireless links. Now,
100 megabits total bandwidth, like you're plugging into a hub.
Yeah. Now, that's gross throughput.
And that's how much
you have some.
What's the size of that radio?